Hello everyone, and welcome back to Technically Unsure, where I'm not sure what I'm doing technically. Today we are going to take a look at a board that a fellow YouTuber has designed. The board I'm referring to is called the Cerberus 2100. We are going to see if it can play 4K 60 FPS with, I'm kidding. So this board is not for that. This is actually an educational board, and it uses old CPUs. Actually, it uses like CPLDs and runs. Anyway, let me show you what I'm talking about. This is the board, right? This is how it arrived. Olimex, I think it's a Bulgarian company. We are going to take a look at it together. So let me take it out of box. Nothing fancy, right? But it's beautiful. So it's in just a clear anti-static bag. First, let me quickly go over the I/O and the chips and ICs on this thing, and then we'll explore more by powering it up. And by the way, the whole design is open source, as you can see it right here. So it's an open source board, and you can play around the code and play around. This is the CMOS. You can play around the code. It was for the BIOS. You can play around the hardware itself. Everything is open source. It's on GitHub. I will probably put some link in there, but also I highly encourage you to go and subscribe to the creator, the Byte Attic. So it's right here. Hopefully you can see it clearly. I'll show it on the other camera as well. So he is the designer, the Byte Attic. And yeah, so this is the board. Let's take a look at it. Let's start from here, right? I guess bottom right. So this here is the programming port where you can just program the BIOS chip. And by the way, as I mentioned earlier, this is the BIOS chip, and it's actually written in C, and it's in you can compile it in Arduino IDE and just use one of those connectors, programmers, and just flash it, upload the code in here. It's open source, as I said. You can modify the code, you can change things around. And this chip here, the BIOS, so its BIOS stands for Basic Input Output System, right? So that's exactly what this one does. This one controls the SD card. It controls the keyboard, which you can plug in from the USB-A port right here. It controls the buzzer, and yeah, so the buzzer, yeah, when they manufacture the boards, they leave this on top of it when they're washing, so you have to remove it, otherwise you probably won't hear much. So this here is the buzzer that also this BIOS chip controls, and also this expansion port, which is 40-pin expansion port. You can interface with this with any other board, Raspberry Pi or any other board. You can interface with these pins and do creative stuff with it. We were going from here, we talked about this, we talked about the SD card, and by the way, it doesn't come with any SD card, so you need to put your own, and it should be FAT32 formatted SD card. And then as you can see, it's clearly labeled here, and it says low mem and high mem. So these are each 32 megabyte DDR5. Kidding. So this is 32 kilobyte SRAM. They are used in your programs, and let's say whatever you're running in here. This one is low addresses, low memory, and this is the high. And there are also two more RAMs, which is this and this. And we're gonna come back to it, I guess. But yeah, this is 2 kilobyte and 2 kilobyte. These 1, 2, 3 connectors that you see here, these are 3 slots, each used for programming the CPLD chips right next to them. So with this one, you can program this CPLD. With this one, you can program this CPLD, and with this, obviously, this CPLD. These are various CPLDs, and he gave these different names. What these are used for, we're going to cover that. Before that, very quickly, this is the USB-A. You need to insert a PS2 compatible USB keyboard. So you can probably get a PS2 keyboard and get one of those adapters and use that, or try a USB port that is compatible with PS2s. And then there is USB-C port, but it's not used for anything data or uploading, downloading, anything. It's just used for powering the board. This is the VGA port, right? So let me show you this way so you can see it clearly. This is VGA port, the USB-C port for powering the board, USB-A port for the PS2 keyboard. This is the expansion slot and 3 JTAG programming connectors. So let's go over the first CPLD, right? So this CPLD is, I believe, called Fat Skunk. This is used for VGA timing. And this. So 2 CPLDs and 2 RAMs combined together kind of drive the VGA, but we're going to explain the details. Basically decides when the information on the VGA display should be updated, let's say, and it provides clock to this second CPLD. And this one is called Fat Cavia, C-A-V-I-A, and this one constantly is reading this 2 kilobyte video memory here and uses the other 2 kilobyte memory over here, which is the character memory, and updates the screen. So to go all over it again, it's very technical, and honestly, his videos are much better than mine. You just go check his videos for more details. I just love the board. I ordered it, I bought it, and I just wanted to show it to you and run it and just see how it does. But definitely check out his channel and subscribe to him. But it's a great board. To summarize, timing of VGA, and this one is actually kind of running the VGA port and uses the 2 kilobyte memory here for the data to be displayed on the screen. And this is 2 kilobyte character memory. So yeah, these all four together kind of, run the show on the screen on the VGA side. These are, and by the way, this one is called Fat Spacer. I'm glad I looked at it because I forgot the name for this one. So yeah, this is Fat Spacer. Here, this part, that bottom side of here, these are the computer part, the brain, the part where actually your program will run and things of that sort. This is, as I said, Fat Spacer. Long story short, it basically makes everything work on this computer, and especially in this part of the board, right? And it's used mainly, for memory selection, expansion triggers, read-write control, clock management, CPU control, serial and parallel translation, and yeah, does it all and runs the show in this side of the board. And two chips in here are basically, this one is I believe, yeah, I know it because I see the Federico Fagin here, and yeah, we're gonna talk about that as well. And this one is Z80 CPU, and this one is 6502 CPU. And I think I read it somewhere. He said that when you buy the board, the BIOS and all these CPLDs already come with the firmware code flashed into it. So you don't need a programmer, JTAG programmer, or a programmer, FTDI program for this one to program the AVR chip in here. You don't need to do that, and it is ready to go, which I'm going to power it on and check that out. Yeah, I think we covered pretty much everything. As I said, I'm just going very on the surface, and he is the creator. He knows a lot more, obviously. I would definitely encourage you all to check out his video to learn more about it. Before I go, I just wanted to mention 2 things on this board. As you can see, hopefully now, it says with a bow of respect and gratitude to Bill Mensch. So yeah, Bill Mensch is the major contributor to the design of the Motorola 6800 8-bit computer microprocessor, and also he's the co-creator of the 6502 processor, along with Chuck Peddle and other engineers at MOS Technology. And then in here it says, dedicated to Federico Faggin with gratitude for his 4 lives. So Federico Faggin, is the designer of the Zilog Z80 microprocessor, which that's why it's right here. And he was also the co-founder and CEO of Zilog. So yeah, that's cool, I think. And I just wanted to show you this. And there's the other labels, Cerberus 2100, that's his logo, and the Byte Attic, that's his channel's name as well. What I'm going to do next is I'm just going to power it on and show you, what happens when you turn it on. I'm going to connect a power USB-C here and a USB keyboard that's PS2 compatible. I should have one laying around, and I will connect a VGA, which I have to connect it to a VGA to HDMI adapter so I can pass it to my capture card. I will be right back. Okay. So I have connected the VGA cable to a VGA to HDMI adapter. From there, I'm connecting it to capture card so you can see what's going on the screen. I have connected a USB keyboard, which is this one for now. Hopefully it will work. And then now I'm going to power it on with a USB cable. Nice. So that was okay. So this is the first thing you will see when you power on the Cerberus. And what you see here, right here, it's what is written in this BIOS chip, right? And you can very easily modify whatever you see here. You can add commands to it, you can change syntaxes, you can change text, whatever you want to do, you can do, and then program it with an FTDI adapter and flash it to this chip, and you will see that reflected right here. Actually, let me show you, why not? Let me show you. So yeah, this is the repo, right? So Cerberus 2100, and if you go here to CAT and then to Cerberus 2100 BIOS, yeah, this is the INO is this extension for Arduino Uno ID, as you may know. And yeah, this is the code. So for instance, if you search for help, which we're going to run, you will see, so these are the commands that you can run, right? So help, save, and the basic Z80, basic 6502, which we are going to run all of this. What I wanted to show you that this code, this whatever you see here in this INO file, is what you see on the screen. So that being said, let's go back to the screen. This is it. So as it suggests, and also it explains on the bottom, it's running the Z80, it's on the Z80 and 8 megahertz speed. So you can change that with make it slow, make it fast. You can switch to 6502. So you can choose which CPLD you want to use for the application that you want to run, right? So if you run a help, this is the list of commands that you can run, which, as I said, it's in that INO file. You can make all sorts of changes to this. It's all open source. So what you see here, you can list and read the contents of the memory. You can run the fast and slow command. You can reset the board. By the way, anywhere, wherever you are, let's say you are into an app, running some app inside some 6502 or Z80, it doesn't matter. If you press F12, it will take you to the first page. So kind of like a soft reset, and escape, for instance, will break the basic app that you're running, just so you know. And what you see here is most of the commands are like self-explanatory. You can read the contents of memory, test the memory, execute code in the memory, move bytes around in the memory, list files, which is going to be the files that are in the SD card, save a memory range into a file, which is going to be on the SD card. All that being said, let me just show you some basic stuff. So I will run the basic interpreter and I will switch to 6502 basic, which is the one that I'm more familiar with, the Commodore C64 stuff. So in order to do that, you just write basic 6502, right? It is loading, there you go. So now we are in Cerberus 2100 and the basic interpreter for 6502. And yeah, so here even you can run some commands that are not really in the, like, let's say Commodore 64 basic. So files, it will let you list all the SD card stuff. And by the way, I stole all of this from that very same repo that I was showing you. He's got a folder in there called SD card. You can grab files from there and put it inside. And that being said, let's do, actually this one I learned it from another YouTube channel. I'm sorry, I forgot the name. I will put it somewhere. So it's basically like one-liner for the maze. So let's do that very quickly. So let's do print mid $/ \\, right? And RND1 and go to, right? So this is the program, and if we do a run on this, yeah, this will print the infamous and famous maze on our screen. So we can also try to run some of the apps, and as I said, the Byte Attic, he's doing everything, running a lot of apps in his video. Definitely go check out his video. He's running a lot of different apps. So let me see some of the apps that he was running. I think he was running the maze one, but from here. So yeah, let me show you actually. You see, yeah, the maze is right there. So what you can do is you can say load and then the app name. And then if you do list, it will show you the commands that are in the file. So this is very similar to what I just wrote, but mine was just one-liner. So you can load various apps that you can see in here, various programs that you can see in here. You can decide that you want to do the 6502 apps, run it on, sorry, this one. So run it on this one or Z81 on this one. And then as I said, when you press F12, yeah, it will immediately take you back to the main page, soft reset of some sort. We can also do the basic Z80. This will drop you to the Z80 version of the basic. So this one doesn't have the files right away. So this one doesn't have that files command, and but still we can load the, I think Soko, he was running on some Sokoban game, Soko Z80, that PRG, that bin, yeah, I think. Now, so let's go back and let's see, list. This one actually will list the contents of memory, not the list of the files. So every time you forget a command, come back here, look at it, and dir is actually the one that you're looking for. Oh, I actually dropped one app from, I got this app from GitHub. Let me try that one, the chopper.bas. So let me try that. So let's go back, basic 6502, load chopper.bas. Okay, and it's a little bit big file. Okay, it's still loading, I think. Was it too big? Let's see. Oops, what happened? I guess, let's wait a little bit maybe. Okay, I give up. I think it is not loading it and it's too big. I will try to message him and ask him about it, but this is just a big, very big, basic app. And I don't know, it didn't load it. Let's do another soft reset and do 6502. Again, let's do files. Let's load one of the things that he was running, right? So the BBC ones are not for the CPU. I'm on the 6502. So what we can do is we can run, oh, by the way, you can run binaries, not the basic apps. So directly binaries that there is also again on his GitHub page. So you can write in assembly, for instance, and assemble it and then run it in here, which is like what I remember is that cell 6502 that I see on the screen. Let's try that. So load cell 6502.bin, run. That's not the syntax. So that's not the syntax. I need to look it up. I know he was running this one, so I have to look it up. 1 second. Okay, I'm not smart. So I completely forgot that we are in the basic interpreter. You're not supposed to do that in here. If you're in the basic interpreter, you're supposed to like load the basic apps. What I was trying to do, that binary, it's not for here. So we can run some basic apps in here, which I did some, but if you have to run that cell 6502, you do that here. Load cell 6502.bin. Yeah, let's try again. Cell 6502.bin. Or maybe it doesn't need cell 6502. Yeah, so it doesn't need the quotation marks. And then if you do run, there you go. That's more like it. So he also does the same thing. I think his capture card wasn't catching up in here, but yeah, this I think mine is doing fine here. Yeah, so this is written in assembly. That's also, as I said, on his GitHub page, so you can check that out. Anyway, I again encourage you to check out his YouTube channel, check out his videos. Very, very educational. And I really like the sport. So I forgot to tell you, but this is like a 219 euros on the Olimex website. So like 230 bucks USD. Who would buy this? I am going to say there are two type of people I would say. That's my opinion, obviously. The people who want to explore that, CPLDs in here, and play around these 6502 Z80 CPUs, and you get a board that has almost everything you might need for like I/O ready for you. You have your SD card, you have your expansion slot, you have your USB keyboard, you have the power, and you have the VGA output, and even a buzzer, right? You have it all in here for you. So if you want to develop some apps, tests, educational, if you want to make yourself familiar with CPLDs, with these old CPUs, learn more about system design, you have the RAMs in here and the expansion slot. Yeah, this is very helpful. And another thing that I always do, I know these days young kids always are encouraged to go and learn Python. But I personally grew up, first thing I learned was BASIC. And I think just by luck, I just came across BASIC and taught myself BASIC and learned BASIC. That was the first thing I learned. I believe that is a best way to enter into programming world and to IT in general, I think. You will learn a lot. You're not going to be able to do a lot in BASIC. It's kind of limited language compared to C or others, but it is a very good programming language for kids to learn programming and be familiar with the concept of old CPUs, the 6502, Z80. These are great, computers. Instead of buying the whole computer, which you can do, I have a big collection of old computers, and I do still collect all those old computers. I repair them and all, but I would give this to a kid and tell them this is the 6502 Z80, show them initial commands and let them have fun with it, right? Run all sorts of program, easy to reboot, easy to start, easy to exit. If you mess up something, very easy. You can, maybe there are already 3D printed cases for this. If not, easily you can create something for this and hand it to a kid. They can learn a lot with this. That's a different use case, but I think when he designed this, his main goal was for people to get themselves familiar with all these CPLDs and the old processors and system designs and playing around all that. So honestly, I like it. I personally think it's a little bit expensive, but you know, it does contain a lot of CPLDs, and these are not cheap. That being said, thanks for watching, and definitely don't forget to check out his channel and his videos. And I will catch up with you. I will see you in the next video. Thank you. Bye for now.